Hello, and welcome to this practice set for graphs of radical functions. As always, please like and subscribe if you find this video helpful, if you find the concepts reviewed in it or the visuals really assist you in understanding the math. Drop a comment or a question below, and please check out the many other playlists and videos on the channel. I'll be sure to link some things at the end of the video for you. So pause the video to work these problems on your own and then come back to check your work and your reasoning. All right, so you'll notice a little box off to the lower right there. I have that set as a graphical check of our work so that once we reason through it, we can then look at a graph and see, okay, did I get this right? Or what's the graphical visual way of processing what I've been asked to do? So questions 1 through 3 are simply state the transformations. Looking at our first one, we have y is equal to 2 square root x plus 2 minus 3. And I always go through these one at a time, kind of from left to right. So that 2 is going to cause a vertical stretch. It's going to cause a bunch of these numbers to be multiplied by 2. So we plug the x in, we do some stuff to it, then we multiply by 2. It's going to stretch it out. Then this right here, this is our backwards from what we think it should be, but this is going to send the graph left 2 units. And then this on the outside here, this should send the graph down 3 units. So the transformations are stretch. Now you might give more information. So you might say stretch by a factor of 2. Okay, so that could be, and then we have, so you might give a little bit more information there. Let's see, next one. We have y is equal to negative, and then another negative, ouch. Okay, so looking at this one, we have a flip. Now this is on the outside, so this is a flip over the x-axis. And then this one is our new one. This is a flip over the y-axis. So this one's going to have 2 flips. It's going to flip over one and then over the other. And then our plus 4 on the outside is, of course, going to send the graph up 4. And then last but not least, okay, so this one's going to require some thinking on this one. Now this is a compression. So this is going to push the graph down vertically, and you want to phrase this however your teacher tells you to phrase it. So I am aware that there are ways that you can say this. I would want my students to say that this was a vertical compression. Now, you could make an argument that if you say compressed by a factor of 1/2, that you're like kind of doubling up on this, so that the compression is implied in the 1/2, so compressed by like almost like a double negative thing. So I would stop at just like compression there, like that's a vertical compression, but always be sensitive to how your teacher wants to do things. Now, here's where it's going to get a little dicey. We have right here, we have that flip over the y-axis. And then we might think that that minus 3 is going to send it to the right 3, but it's not. It's going to send it left 3. And then the plus 5 is going to make it go up 5. Now, if you need to kind of digest that a little bit more, this one could be rewritten like this, where we factor the negative out. Okay, and if you need to go back and look at the lesson for this, go back and check out the lesson, which I usually link in the description box, but I'll try to remember to do that. But go check the lesson on that, because we reason through that. That's like the order that you do the transformations in. Okay, now let's take a look at the graphs for these. Okay. So looking at these, so we have stretch left 2 down 3. Now the stretches and compressions are hard to see, so I'm not going to locate the graph by using the stretch. Like I'm not going to look. Now I think I can look at that and see which one of these is stretched, but let's go with the left 2 down 3. So if I start here and I go left 2 down 3, that helps me find the graph that I'm looking for. Okay, so left 2, down 3. And then when I look at that blue one, it does appear to be stretched. Hard to see. You could like pick out a couple of points on there to say like, okay, yes, I believe that that was stretched out. But even if you look at it compared to the others, it does look like it's being pulled in that vertical direction. All right, so this next one is just strictly up 4. Okay, that's our translation. So coming over here, I can find, okay, that's my green one. Okay, that's up 4. And now looking at the flips, it is flipped over the x-axis, and that instead of heading up, it is now heading down. And it's also flipped over the y-axis because instead of heading right, it is heading left. And whoops. So we do have both of those. So we're like flipped twice and up 4. And then for the last one, left 3 and up 5. So left 3, up 5, that's going to be my orange one. Okay, and I can see, yes, it is flipped over the y-axis. I know that because it's heading left instead of heading right. And is it compressed? Well, again, harder to see, but yes. And if you compare it with the other two, yes, it does appear to be like flatter, like somebody's like sitting on it and pushing it down. So again, hard to see those. Now, if you got this one wrong and you said right 3, the moment you go and look at that graph, you can see like, oh, okay, like that's not right. So there isn't anything that goes right 3 and up 5. Like there's just nothing there. And when you see that, that should cause you to go back and say, all right, did I miss something when I was doing this? Did I miss something that was like in the lesson that I should have remembered? And you don't want to feel bad about that. I tell my students all the time that it's totally okay to make mistakes. You just want to learn from them. So you're like, oh, okay, well, I missed that. And you go back and you go look at that part of the lesson again, or you go back to your notes that you took and you refresh that information. And that's going to help your brain lock that information in so you are less likely to forget it at some other point. All right, now these ones are to sketch the graph by hand. So this is kind of taking your transformations to the next step. I'm going to use a Y when I rewrite it just because it's easier. And looking at this first one, I'm going to have a flip over the x-axis. This is going to make it go right 6. And what you're seeing there is a sloppy square root there. Right? Okay, so the square root cuts off after the 6. The plus 1 is not under it. And so this means it goes up 1. Always we want to try to graph those as, write those as accurately as we can. So I'm going to start by just anchoring this. So I'm going 1, 2, 3, 4, 5, 6, and then up 1. So I'm going to go grab my like anchor spot right there. And then I'm going to deal with how is this transformed. This one is flipped over the x-axis. So it's going to go like that-ish. Okay, just flipping it over the x-axis. You might like kind of think, oh, yeah, there we go. There's our flip. Okay, so I know how I want that oriented. And again, a quick reminder, these are just sketches. Okay, when we're doing this by hand, we're not going for the most accurate graph ever. We are just trying to get an idea of where this graph is located. Okay, so looking at this one has a flip over the y-axis, and then it's going to go down 1. And so I'm going to look at that down 1, and then looking at, so there's my anchor, and it's going to flip over the y-axis, so it's going to go that way. And you might do this, like, okay, there's my flip over the y, like kind of get that transformation, and then say, okay, it's that, except it's going to go down 1. So something like that. And last but not least, we have this one, number 6 here. This is maybe the most straightforward of them. So it's going to be left 3 and up 2. I don't know why I put a plus sign there. No idea. So left 3, up 2. So 1, 2, 3, up 2. So we get like kind of where our end point is, and then we have not done any flipping on this. So the orientation will be the same as for the parent. Just try not to make it look like a straight line, okay? What I've told my students when it comes to sketching the graphs of these is two things that I would take off points for. I will take off points if it looks like a straight line. So kind of what I just did there and erase it. The other thing I'll take off points for is if your graph like looks like it turns around and heads in the other direction. Again, these are quick graphs. These are like, where is it and how is it oriented? Not, do I have every point on there sketched accurately? Like, no, in fact, I didn't even put any tick marks on here other than the ones that I needed to find the endpoint. So something you might get from this is, how much detail were you doing on it? And yeah, if it took you like 30 or 40 minutes to do this, like probably you're overkilling. If you need an accurate graph, you're going to use Desmos, you're going to use a graphing calculator, something else. So let's go ahead and check these. Do they look like they're like sort of in the right spots? Yeah, it seems that way. This first one is right 6 up 1. So if I come over here, right 6 up 1, that's the blue one there. And yes, my graph there looks reasonably close to the blue one. Again, if I need a really accurate graph, I'm going to do it on a graphing utility. This is just like my quick one. This one just goes down 1. So looking at this is the green one. So down 1 and then heading up and to the left. So yes, that graph does look like this one, reasonably close. Okay, and the last one is left 3 up 2. So I go left 3 up 2. That's my orange graph. And yes, this one does appear similar to that. If you're wondering, well, yours look like they're all stretched out. That's the scaling. That is the difference between like really keeping your X's and your Y's like all equally spaced, all of that, and just kind of doing a quick little sketch for the orientation. So, but yes, it appears that we have done 4 through 6 correctly, which is nice because I'm recording a video and I don't actually want to make mistakes with that. All right, so this next one is state the domain and range. And what I've got is 7, 8, and 9. All done separately with the Desmos check will be in this box down here. So for this first one, I am going to again, kind of bring it back. We're like layering on here. Okay, so this goes, flip over the X. It's going to go left 2 and down 3. So what am I going to do? I'm going to take a look at this. Okay, so it goes left 2, down 3. And it flips over the x-axis, which means it's going to be looking like that. And so looking at where is this graph, I can see my x, we're going to be leveraging the -2. On the y, we're going to be looking at a -3. And so I would say my domain is X is greater than or equal to -2, and my range Y is less than or equal to -3. And I'm doing that really by backing up this whole skill set and saying, okay, what are my transformations? What does this graph look like? Could I do that without the graph? Yeah, probably, but I feel better about it if I can see the graph. And then let's go ahead and take a look at this. So yeah, this looks pretty good. This is what we're looking at right here. X is greater than or equal to -2. Y is less than or equal to -3. If you are asked for this in interval notation, okay, you've got your -2 and infinity. So this is -2 to infinity. And this right here is -3, and that's going to negative infinity. So we're starting at negative infinity and going to -3. Make sure you're always going from least to greatest. I was on a roll there. So nothing is smaller than negative infinity. Okay, I don't know what that would be. Okay. Number 8. Okay, so this looks fun. Alrighty, so we have a lot of stuff going on. We have a flip over the x-axis followed by a flip over the y-axis. Now this I would normally say is left 3, but we know we've got that weird like flip and then the order of our transformations there, so that's actually going to be a right 3, and this will be up 5. So my inclination is I am not going to just wing that. I am going to go take a look at it. So we're going to go right 1, 2, 3 and up 1, 2, 3, 4, 5. And that's going to give me like my anchor point. So whatever I got going on, I'm going to be using the 3 and the 5. Okay. Now to flip over both, to flip over the x-axis sends it this way, to flip over the y-axis sends it this way, and we want it to do both. So it's going to look something like that. Alrighty. So looking at my domain, x looks like it's going to be less than or equal to 3. And my range y also is less than because it's heading down, less than or equal to 5. Let's check it on Desmos. Yay. Okay. And again, if the Desmos graph looks different than my hand sketch, like that, it has to do with scaling, how something is zoomed in or out. My students will stop me a lot and they'll say, well, my graph doesn't look like yours. And really all it is like my graph is zoomed in differently. So you have a different scaling on it. What matters is the actual location. So if you look at where that point is, that is the 0.35 right there. That's the part that matters, and like kind of the direction of the graph. So again, if you're doing this on using interval notation, you've got negative infinity and you're stopping here at the 3. So that's negative infinity to positive 3. And your y-axis is starting at the negative, or y. Yeah, anyway, the highlighting is down there at negative infinity and stopping when you get to the 5. Okay, last one. So we have number 9. And we have x plus 3 minus 2. So this is left 3 and down 2. So we'll take a peek at that. Left 3, down 2, with no other transformations on it. So no flips this time. Okay, and so it should look something like that. Breaking it down, we've got -3 and -2 are like the points that we're working with. Okay, so -3, -2. And these are both greater thans. So x is greater than or equal to -3. And y is greater than or equal to -2. You can also do it this way. If you think algebraically, that right there must be greater than or equal to 0. Okay, and then if you subtract the 3 from both sides, x must be greater than or equal to -3. So that's another way of reasoning it out. I don't want to throw that out there to confuse you, just take options. All right. So looking at this, x is greater than or equal to -3, y is greater than or equal to -2, and you can see that confirmation for where the highlighting is. Again, if you're doing interval notation, okay, in this case, we are starting at x is -3, and we're going out to infinity. And the y value here is starting at -2 and going to infinity. So -2 to infinity. Last but not least, plot points to sketch the graph and verify with a graphing utility. So I did mention in the lesson, we really focus on square roots here. Those are the most common kinds of radical functions that you would have to graph, but that doesn't mean you might not see some other ones. So we're going to plot some points. And if you watched the video lesson for this, okay, if you watched the video lesson, you know that when I did this with the square root, I was trying to pick things that I knew would have a nice square root. So I picked like 0, 1, 4, 9, 16, and so forth. So for this, we're going to pick things that we know have a nice cube root, and that's going to be our perfect cubes. And what is different with your odd index roots there is that you actually can take the cube root of a negative. So that is like one of those things that goes back to what a cube root is. So I can actually put in like a -8. Well, because if I were taking the cube root of -8, I could break that into -2 times -2 times -2, which means the cube root would be -2. So you might not have thought to do that, but there you go. We'll look at -1. Well, the cube root of -1 is -1. 0 is 0. Now, this might be where you picked up, okay, where the cube root of 1 is 1, and the cube root of 8 is 2. Now, you could pick other things. You could do like the cube root of 4. It is not going to give you a nice number. But all right, so looking at this. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right. So we have -8, -2. So it's going to be a point right there. And then -1, -1. We got the point 0, 0, the point 1, 1, and the point 8, 2. Okay, and so what it looks like is we have something like that going on. Okay. It's got some similarities to a square root graph, especially if you look at greater than or equal to 0, except that now because you can take the cube root of negatives, you don't end up in imaginary land. The graph does extend into your negative x's, and it looks like it's doing something similar, maybe like with some reflections going on, some symmetry. You can get into some higher level concepts, like looking at like odd and even functions, that kind of thing. But for here, you're just sketching the graph. And then we're going to verify that with the graphing utility. And this is like an interesting thing to do. And I'll try to record a short with how to do this if you are trying to verify or plot points to graph an unfamiliar function. So you can actually input the function into Desmos and then generate a table and then customize that table to show the points that you want, but you can see that that does verify what we did by hand, and then you can see the graph verified over there. So some tools that you have, and of course in our practice sets, we want to stretch like our knowledge and mastery of what we've covered. Okay. Well, that's it. Please like and subscribe if you found this practice set helpful. If it helped you to review some stuff or catch some mistakes, some misconceptions, drop a comment or a question to engage. I'd appreciate hearing what you thought. And then please check out some of the other videos on the channel. We have videos and playlists all on multiple choice strategies and Desmos help videos and algebra tiles and so much more. So please take some time to explore the channel and see what we have that is helpful to you. And I will see you in a future video.